Today, today I'm going to present quality programs for manufacturing. These are the topics that I'm going to cover. You can see from the green box, right? So the quality control system is highlighted and how does it connected between manufacturing system and also manufacturing support system in a manufacturing operation. Okay, there are two aspects of qualities by Duran and Zina. First of all, we talk about the qualities in product features. It is design, configuration, size, and weight, function, and performance. Distinguish the features of the model, aesthetic appeal, ease of use, available of the option of the products, reliability and the dependability of the products, durability and long service life, serviceability, reputation, and of the product and producer, responsibility. All these product features is responsibility by the design department. Secondly, we talk about the freedom from the deficiency. We talk about the absence of the defects, no early failure, conformance of to the spec, component within the tolerance, and the freedom from the deficiency is responsible by the manufacturing department. So this is the difference between the traditional and modern quality control. Okay, in the traditional quality control, quality is defined by the company. It talk about the product acceptance. Mainly the objective is to success and product profit earned in the short term. And the quality is accountable by the manufacturing department, particularly to the inspection personnel, mainly to eliminate the defects. Okay, so the elements that they talk about in a traditional way is the statistical quality control, looking into the control chart and also talk about the acceptance of the sampling. So basically, they will address the quality products upon the raises of the problems and they will solve the quality performance from case to case basis. So the approach is more towards like a disciplinary and also the penalization. Then normally their problem solving and decision making is limiting within the supervisor and also the employees involved only. Okay. So under the modern quality control, quality is defined by the customer and also talk about the product's quality. And the objective is focusing on the long term and also the sustaining approach. And then quality is everyone's responsibility. Besides that, in the modern quality control, they will deploy the QC technology to drive the waste elimination and also improve the efficiency. And besides that, the second element, they will talk about the continuous process improvements to resolve the issues systematically. And example of the quality control technology are quality engineering, quality function deployment, and also online inspection and others. So there are different approach. Their approach is they look into the opportunity and they actually recognize the effort as an achievement. Okay, so the modern quality control is involving the top management down to the employee. They make a decision based on the substantive data. What is product variation? There are two types of product variation. One is a random and other one is assignable. Random variation is talking about the result from the intrinsic variability in the process. Normally, the process is operating normally. So the human variation is from cycle to cycle and a very minor variation in the starting of the material and also or the machine vibration. Okay, so if only the random or common causes of the variation exist in the output of the process, that is stable and predictable. While for the assignable variation indicating an exception from the normal operating conditions due to the human error, it could be caused by the untrained or incoming material defects or the machine performance due to wear and tear, failure, out of spec. So if a assignable or special cause of variation exists, the output of the process is not stable and not predictable. Process capability is talking about the ability to meet the design spec within the tolerance. which is set by the engineering design or the customer requirement. There are two types of measurement for quantitative measurement to define whether the process is capable or not. So the first one is the CP, process capability ratio. This is the formula. So a ratio that to determine whether the process is meeting the design spec or not. Okay, if the process, if the CP value is carry more than equivalent to one or more than one, which means very healthy. So CPK is another quantitative measurement. We call it process capability index. It's talking about a proportional of a three standard deviation between the center of the process and the nearest specification limits. So this is the uh, formula is talking about the minimum of the process mean, upper spec minus process mean, and then divide by the three standard deviation, or the means minus lower spec limits and divide by the three standard deviation. Both upper or lower spec limits is equals to 1. Okay, then the process variation is centered and the process is capable when it's produced within plus minus 3 standard deviation. This is the example of a CP. Okay, if let's say we talk about in a Great Eastern Insurance claim process, right? The process mean is 310 minutes and the standard deviation is 0.516 minutes. Let's say the design spec is saying that in order to meet the customer expectation is 210 minutes plus minus 3 minutes. So the upper spec is 213 and the lower spec is 207. Okay, so we wanted to know whether the process is capable or not. So we input based on this formula. The CP value is 1.938, which means it's very capable. So what does it mean? It carry 1.938, which means 99.73% of the process output are within the spec. So with the only carry with less than 4 claims per million non-conformance. Okay. Then this is the example of CPK. Okay, let's say we would like to determine as part of the improvement, right? We have developed a new process to cut the screw insert for a company. Okay, then as the goal is not more than 3.4 defects per million, and the existing machine carry with 1.0 CPK value, and then this is the spec. Okay, it should be within plus and plus minus 0.01. The thickness, the spec is 0.250. Okay, we input everything accordingly. This is the formula. So the CPK value is 0.67, which is less than 1, the existing CPK, which means that the new machine should not replace the existing machine, because if you replace, then you are not able to meet the goal. Statistical process control, SPC. So it's a process that used to monitor a standard, make the measurements and analyze and take the corrective action as a product or service is being produced. The objective is mainly to improve the quality of the process output, reduce the process variables, improve the process stability, and solve the problems. Okay, how do we implement? We can standardize the process uh, through management commitment and leadership, and then implement a team approach in problem solving, provide the SPC training for everyone, and focus the continuous improvement throughout the organization. And last but not least, recognize and comprehend comprehensive communication system to recognize a successful SPC effort. So as part of the SPC, we will actually leverage the control chart. The control chart that presenting the process data over the time is showing the upper control limits and lower control limits. If let's say the data is within the control limits, which means the process is permitted to continue. If the data is more than is exceeded out of a control limit, which means we need to stop the process and assign the cost, and determine the assignable cost and remove the assignable cost. Okay. So Six Sigma is a discipline, statistical based and data driven approach, and also talk about the continuously improvement methodology to reduce the defects. mainly to improve the quality of the product and services, improve the process capability. Then it will actually return in terms of the cost saving, saving time, and improve the customer satisfaction. The difference between Six Sigma and also the SPC is Six Sigma is using six standard deviation, while SPC is using three standard deviation. Okay, so Sigma is a comprehensive system whereby we talk about the strategy, the discipline, the seven tools of the TQM in order to achieve and sustain the business process. The strategy is mainly focused in terms of the total customer satisfaction. The discipline is utilizing the DMAIC cycle, okay, to define what is the problems, measure and quantify the problems, analyze and identify the root cause of the problems, improve, identify the corrective action, preventive action solution, then sustain the solution. Okay, so we will talk about the seven tools of the TQM, like chart sheet, scatter diagram, how to use the cause and effect diagram, Pareto diagram, flowchart, histogram, and SPC in order to improve the quality performance of our process. Takuti method in quality engineering is a broad range of the engineering and operational activity to ensure that the product's quality characteristic at the nominal or target value. So total, there are three methods to improve. So the first one is quality robustness. We talk about the consistencies of the process to build the product to meet the customer requirement, despite there is many adverse conditions. Okay, a design in which the function and the performance of the product or process are relatively insensitive to the variation of any noise factor. The second method is QLF, quality loss function. It's a mathematical functions that identify all the costs that tied to the poor quality performance, and so how does it impact to the cost. Okay, so normally the loss cost factor are defects, malfunction, service, repair, maintenance, and so on. So you can see the features here. How does it type relate the best of the quality in the best quality that minimum the losses and unacceptable quality that causing high losses. Okay, so we will talk about the target. The third method is the target-oriented quality. It's a philosophy of a continuous improvement to bring the product exact on the target of the spec. Okay, and then this is the upper control limit. This is the lower limit. You see, the target-oriented quality yield more products in the best category, and then the conformance oriented quality keeps the product within three standard deviations. ISO is a set of quality standard developed by ISO in year 1987. It's a standard for the system or procedure used by a facility. It's not industry specific that talk about affects the qualities of the product and service. Okay, focus on in terms of the quality management procedure through the leadership commitment, details of the documentation, the instruction, and also the record keeping. Organization that involve documenting quality procedure. It also consists of audits, on-site assessment. Okay, and then in year 2000, right, ISO actually has revised the ISO 9000 standard by integrated the leadership by the top management and also customer requirement and satisfaction into ISO 9000 2000. 9001 2000. That's all from me.